Hi class, in lesson 4.5 we are going to be multiplying decimals. Learning targets for today. We will be using a hundredths and decimal grid to multiply two decimals. We are going to multiply decimals by whole numbers, multiply two decimals, use fractions to calculate the products of decimals, calculate the product of decimals using fractional forms, and we are going to estimate the product of decimals as well. Let's take a look at problem 1 on page 268, modeling decimal multiplication. It says that you can use tenth or hundredth square grids to model multiplication of decimals by whole numbers. If we take a look at the first example, 3 times 2 tenths, you can see in the model that we have 3 equal sized parts with 2 tenths shaded in for a product of 6 tenths. In the second example, we have 2 times 25 hundredths. So we have 2 equal sized parts of 25 hundredths shaded in for a product of 50 hundredths. And finally, in the last example, we have 5 times 3 tenths. We have 5 equal sized parts with 3 tenths shaded in for a product of 1 and 5 tenths. And let's remember that multiplication is repeated addition, so you can see also in each of the examples. The first one, we have 2 tenths added together 3 times. In the second example, 25 hundredths added together twice. And in the final example, 3 tenths added together 5 times. Let's go ahead and turn to page 269 and take a look at number 1. Use the hundredths grid to calculate the product of each expression and make sure that you show your work. I'll give you a couple minutes to work on letter A, B, and C with your group members. Here are what your answers should look like for A through C. For letter A, 4 times 2 tenths. I have 4 equal sized parts shaded in with 2 tenths in each for a product of 8 tenths. For letter B, 5 times 2 tenths. I have 5 equal sized parts shaded in with 2 tenths in each for a product of 1 whole. And for letter C, I have 9 equal parts of 3 tenths shaded in. 9 times 3 tenths would be 2 and 7 tenths for the product. Let's go ahead and turn to page 270. Up at the top it says, similar to how you used area models to multiply fractions, you can also use hundredths grids to multiply two decimals. So let's go ahead and take a look at the example that they have here for us. We have 5 tenths times 7 tenths. So when we shade 5 tenths of the grid in, and we also shade in 7 tenths of the grid, the area where the shading overlaps is going to represent the product. So 5 tenths times 7 tenths is going to give us 35 hundredths for our answer. Go ahead and do number 2 with your group members. Go ahead and do letters A through D. For number 2, use the hundredths grid shown to model each expression, then calculate each product. Let's take a look at letter A. I have my 2 tenths shaded in red and my 8 tenths shaded in black. The overlapping region then represents 16 hundredths, so 2 tenths times 8 tenths is 16 hundredths for the product. If we take a look at letter B, 3 tenths times 6 tenths, my 3 tenths is represented in red, my 6 tenths is represented in black. The overlapping region, 3 tenths times 6 tenths would be 18 hundredths. For letter C, I have 1 whole that is represented in red, and I have 6 tenths represented in black. 1 times 6 tenths would be 6 tenths for my answer, for my product. And for letter D, I have 7 tenths in red. I also have 7 tenths in black, the overlapping region, 49 hundredths for the product. Let's go ahead and turn to the top of page 272. You can use fractions as well to calculate the products of decimals in addition to using models like we just did. What we want to do is change the decimals to fractional forms using 10, 100, or 1000 for our denominators. So take a look at the problem that they give us, 4 and 5 tenths times 9 tenths. So we want to take 4.5, turn that into 4 and 5 tenths in fraction form, and we want to take 0.9 and turn that into 9 tenths in fraction form. And just like our helper is telling us, remember then to convert any mixed numbers to an improper fraction before we multiply. When we have our improper fractions and we get a product, in this case 405 over 100, we can convert that back into a mixed number and then come up with our decimal answer of 4 and 5/100 like the example shows. So let's take a look at number 3 and let's get some practice in changing decimals to fractions in order to calculate the product. Number 3 says calculate each product using fractional forms of each number. So go ahead and do letter A, B, and C with your group members. So here is what you should have come up with for letters A, B, and C. If you look at letter A, 2.5 times 1.3, we want to convert both of those into fractions. 2 and 5 tenths times 1 and 3 tenths, we turn them into improper fractions, carry out the multiplication. 3 and 25/100 is our decimal product. For letter B, 2 and 6 tenths times 1 and 3/1000, turn those into mixed numbers, improper fractions once again, and you carry out the multiplication. You get 2 and 6,078 10,000ths for your product. And finally, letter C, 2 and 37/100 times 2 and 5 tenths. Again, carrying out the multiplication using improper fractions, 5 and 925,000ths for your product. Let's go ahead and skip to number 5 on page 273. Emily is buying supplies for her camping trip. She wants to pack light and healthy snacks. She notices these choices at the health food store. So take a look at the table. Emily decides to buy 2.6 pounds of trail mix and 0.4 pounds of fruit rolls. Let's go ahead and do letters A, B, and C with your group members. First, estimate the cost of each item that Emily will purchase. In letter B, write each decimal in fraction form with a denominator of 10, 100, or 1000. Then multiply the two fractions. And finally, compare the product you calculate to your estimate. And in letter C, figure out how much Emily spent on the trail mix and the fruit rolls. So let's take a look at A, B, and C. First, what I did in the table is rounded the cost of the trail mix and the fruit rolls. The trail mix to $6, the fruit rolls to $4. For letter A then, as far as estimating my cost, the trail mix right around $18. 3 times 6, the fruit rolls, about 0.5 times 4 would be $2. In letter B, there's the work that you need to show, again, taking your decimals, converting them to mixed numbers. The trail mix cost would be $14.69. Fruit rolls, same exact thing, taking my decimals and converting them into fraction form. The cost for the fruit rolls would be $1.74. When you add together the $14.69 and the $1.74, you get a total of $16.43 that Emily spent. Let's go ahead and turn to problem 2 on page 274, looking at estimating products of decimals. Estimation can also help you with multiplication of decimals. If you do not need the exact product, you can estimate to determine the approximate product. If you have an estimate, you can use it to decide whether your answer is correct. An estimate can also help you place your decimal point correctly in the product. Let's take a look at Kenny's example. He's looking to multiply 32 and 64 hundredths times 7 3/10. So he estimates his two numbers. 30 times 7 is going to give you a product of 210. Next, he calculates the product, carries out his multiplication, and comes up with 238.272 for his answer. So because of his estimate of 210, Kenny knows the product will be larger than 210, so he knows that he must place the decimal point after the 8 for the product to be 238 and 272 thousandths. Another thing you can remember when you are figuring out where to put the decimal point is that the number of decimal places in the product is the same as the sum of the decimal places in each factor. So if I have 32 and 64 hundredths, the 6 and the 4, if I have 7 and 3/10, I have that 3, so I move it over 3 spots in my product. That's another way to help you remember where to put the decimal point in your answer. So let's use that rule that we just wrote down for number 1. Take a look at letter A, B, and C. Look at the digits to the right of the decimal in each of the factors and try to place the decimal point in the correct spot for letter A, B, and C for each product. Let's take a look at letter A. If we would estimate 50 times 1, we should know that our product would be right around 50. If we take a look at the digits to the right of the decimal point, there are 3 total, 1 in 52.6 and 2 in 83 hundredths. So my answer would be 43 and 658 thousandths. For letter B, same thing. My estimate would be right around 4 for my product. I have 1 digit to the right of the decimal in 7.9, 1 digit to the right of the decimal in 0.6, so I move my decimal point over 2 spots, 4 and 74 hundredths for my product. And finally for letter C, 1 times 25 is going to give you 25 for your estimated product. I have 2 digits to the right of the decimal in 94 hundredths, and I have 1 digit to the right of the decimal in 24 and 9/10. So my product would be 23 and 406 thousandths. Let's finish up today by turning to page 278 and taking a look at number 5. Paula thought she had the multiplication of decimals rule memorized when she multiplied 3.65 times 4.22 and got 15.403 on her calculator. She said, "I thought there should be 4 decimal places, but the calculator only has 3 places." So let's go ahead and take a look at letter A. Explain to Paula why the calculator is indeed correct. I'll give you a couple minutes to do that with your group. What we need to explain to Paula is that the calculator doesn't show the 0 in the 10,000s place because 15.4030 would be equal to 15.403. 0 means there is no value in that specific place value, and it is the final place value in that decimal, so the calculator doesn't need to show that last 0. That's going to be it today for lesson 4.5 and multiplying with decimals. Please let me know if you have any questions. Thanks.